General technical characteristics of smart grid systems created by Geatron power units for parallel operation with the grid and Spekular Tron for isolated operation from the grid. General characteristics of the smart grid system.
Transportable, plug-and-play connections, modular and expandable with standardized measurements, flexible with the ability to modify the mode of operation.
Electronic synchronization. Smart grid system, common DC, bus system.
Common high-voltage DC bus involved in all processes. The working voltage of the common DC bus has stable dynamic behavior with zero current balance. The common DC bus allows sequential or simultaneous operation of all components. The common DC bus allows renewable production to be fed entirely into the consumption circuit or the battery, distributed simultaneously between consumption and the battery, or fed into the consumption circuit while being combined simultaneously with the battery.
DC-AC inverters of the smart grid system.
3-level voltage inverter capable of operating in a single stage or in 2 stages in battery management. Bidirectionality, regardless of the AC generator with which it interacts. Direct line AC connection of the generation. Overload capacity in grid forming mode is 125% for 10 minutes, 150% for 1 minute, and 300% for half a second. In grid forming operation, consumption is divided by DC-AC equipment, allowing distribution to be determined. Power factor operation in all 4 quadrants of operation. Compensation of phase imbalance, up to 100% of one phase supporting asymmetrical consumption. Simultaneous reactive power generation, without penalizing active power generation capacity. Capacity to operate in parallel with the grid as current regulation or voltage regulation. Grid following, or isolated from the grid as voltage regulation grid forming. In voltage regulation mode, it is capable of replicating the behavior of a synchronous machine, creating a completely isolated and independent network, operating in parallel with an electrical grid, raise the voltage from 0 volts, black start, interconnect several DC-ACs in parallel without them having to communicate with each other thanks to the internal droop function, and generate a virtual DC-AC impedance that guarantees the necessary attenuation for parallel connection.
DC-DC converters for storage, power management of the smart grid system.
Bidirectionality. Operating range with a lower value of 0 volts DC and a higher value of high voltage DC. Ability to simultaneously combine different storage technologies to the same common DC bus.
Smart grid system, battery pack.
Minimum cycle life of 6,000 cycles. Minimum lifetime of 10 years. Maximum discharge of 100%. Active balancing between batteries using DC-DC converters. Passive balancing between all cells that make up the battery using a BMS, balance management system. The deviation for open circuit voltage is 5% for charge states above 10% and 2% for charge states below 10%. For continuous charge and discharge cycles, the charge rate is 1C for states of charge below 60%, and the discharge rate is 1C for states of charge above 30%. For 30-second pulse charging and discharging, it reaches a charging rate of 2C for charge states below 60% and a discharging rate of 2C for charge states above 30%.
Generator assistance, if available, of the smart grid system.
Startup and shutdown control of the generator set from the smart grid system control system. Double-walled fuel storage tank with automatic fuel transfer system.
Management and control system of the smart grid system.
Integrator of all electronic components, control components, measurement points associated with the common DC bus, and measurement points associated with the electrical grid, the generator set, and consumption. Management of the electrical supply in the electrical grid, originating exclusively from photovoltaic generation. Management of the electricity supply in the electrical grid, originating exclusively from storage. Management of the electricity supply in the electrical grid from photovoltaic and storage simultaneously. Operating in isolated mode from the grid, smart grid. Continuous management of the electricity supply of 100% of the apparent power required by consumption. Operating in parallel mode with the grid, parameterization of charge and discharge management from and to the electrical grid based on pre-established schedules and power levels, and based on battery charge states. Operating in parallel mode with the grid, management of the power supply required to cover excess power consumption over the contracted power from the electrical grid. Operating in parallel mode with the grid, continuous management of reactive power supply without penalizing active power generation. Control of all necessary actions of the auxiliary grid supply equipment, generator set. Manual and autonomous on-off switch with the ability to self-manage, with the ability to autonomously and independently manage events. Autonomous management of the change between the different operating modes required by each of the components depending on the operating mode required at any given time. Parameterization of all parameters associated with battery operation, with the possibility of parameterizing values for different storage technologies. Can be operated entirely locally through the proper use of the documentation provided. Real-time monitoring of all system processes in numerical and graphical format. Automatic generation of customized daily, monthly, and annual operation reports based on the information stored on the data server.
Smart Grid System Communications.
Access via a secure VPN communication link.
Smart Grid System Operating Modes. Standard modes of operation in parallel with the public power grid. Geatron Power and Spekular Tron versions.
Mode 1. Parallel operation with the public power grid. Managing the renewable source to provide savings in electricity consumption. Managing the battery to cover excess power consumption in relation to the power contracted from the power grid, while allowing for a reduction in the power contracted from the power grid. Managing battery recharging from the electricity grid, and managing battery recharging from the generator, if applicable. Mode 2. Parallel operation with the generator, supplying power to it when it is operating as an emergency system, thus providing greater autonomy to the generator's diesel consumption and supplying the generator's supply circuit with renewable power.
Standard modes of operation isolated from the public power grid. Spekular. Tron version.
Mode 3. Operation in isolated mode as an emergency system, using the generator set as an auxiliary support system. Mode 4.
The most advanced operation mode.
Operation as a double conversion, uninterruptible power supply system, isolating such consumption from possible failures or deficiencies in the electrical grid and the generator set, using the electrical grid as a priority and, failing that, the generator set as an auxiliary support system.